Today we're going to talk about object-oriented programming, and you might remember that a struct was our first user-defined data type. So if you're having a little trouble remembering what the struct was, I suggest you go back to the video from the intro course for a refresher. Okay, but basically we use the struct to describe something from the real world, like a student or a point or a mathematical function. Okay, a structured data type groups related data together into one unit. Okay, so let's look at this program here that uses a struct. Okay, so a struct really just defines a new data type, just like int is a data type and float is a data type. I'm creating this data type that represents a computer, and all this is a group of related data. All the data is about a single computer. So there's an integer for the number of processors, a float for the RAM in gigabytes, a string for the serial number, and maybe a vector of input and output devices like keyboards and monitors and mice. Okay, so like I said, this defines a new data type. One can use this data type to create variables or objects. The object is the name that we give variables that are created from structs, where each one has its own copy of the data. Okay, so if we were to look at main here, here we're creating two variables, two objects called C1 and C2. Okay, now if we were to look at memory, right, we have our memory here. Some room set aside for the object C1 and some room set aside for the object C2. And of course, each one of these objects has its own copy of the data members. Okay, so there's never any chance of, setting the value of C1 and having it have any effect on the variable or the object C2. Okay, so these are two separate and distinct variables that are sitting in memory. And of course we use dot notation to access the data members. So if I wanted to say, for the object C1, set the number of processors equal to 4, okay, that basically means go find the thing called C1 and look for the data member that represents the number of processors. Okay, and set that piece of data equal to 4. It of course has no effect on the object C2. Okay, one benefit of creating structured data types is that we can think of related data as a whole. So when we call a function to manipulate a computer, we can pass a single object into a function. Okay, instead of, so let's imagine we're going to have this function to print a computer. Well, the parameter, we only have to pass in one parameter, right? Because all of the data about a computer is wrapped up in this object of type computer. Compare this with code that doesn't use the structured type, and you'll see we have this long list of parameters that we have to pass into the function. Okay, where logically, really, all these pieces belong to a computer, but there's no easy way to kind of collect them into one unit. Okay, and in fact, that's exactly what one of the benefits of using this structured data type is. We actually can do that. Okay, it's a little bit simpler for us to deal with the idea of a computer when we collect related data together in one new type and then create objects from that type. So remember, the struct is the cookie cutter and the object is the cookie. I probably mentioned that several times in that first video. To fully represent an idea from the real world in software, it's not good enough simply to collect data, though. We also need to collect the operations that act on that data. Okay, so an abstract data type is a collection of data and operations that act on that data. That represents some real world entity. So a struct collects data. We're going to learn about this thing called a class, which also collects data, but it adds these methods or functions that work on that data, and then we wrap these into a single logical unit. So in C++, a class is a way to create an abstract data type. Okay, the operations in an abstract data type, those represent the interface to the ADT. Okay, the interface tells us what we can do with the abstract data type, but it says nothing about how it's implemented. We abstract those details away. Okay, so this idea of abstraction is important. Humans rely on abstraction quite a bit. Okay, so let's look at an example here. We always talk about an implementation and an interface when we talk about abstract data types. Okay, so let's start not in the world of software, but in the real world. Right, we have cars, right? Cars have really complex implementations. So what makes up a car? Well, we have carburetors. We have fuel injection systems. Fuel injection. We have rotors. Okay, and literally thousands and thousands of other unique parts. Okay, but what is the interface to a car? Well, the interface to the car is really quite simple. We have a gas pedal. We have a brake pedal, and we have a steering wheel. Okay. We've abstracted all those complicated implementation details into a very simple interface. Okay. And this is a really good thing, because if you had to know about every single implementation detail to drive a car, there wouldn't be many of us who could comprehend all of the mechanics of a modern day car. Okay, now let's go to the software world. We have the same idea of implementation and interface. So there's this data type called a string, and the string is an abstract data type. So let's start with the interface this time. Well, what can we do with a string? We've all probably gotten the length, and maybe we've called the find method. You can find one occurrence of a string inside another. We might have used this method called substring, which pulls out one part of a string from another. That makes up the interface for the string type. Okay, but what about the implementation? Well, I don't really know. Okay, why? Because the implementation is hidden from us. Okay, and you know what? That hasn't stopped me from using the string at all. In fact, I've never really been concerned enough where I wanted to go and look for the source code. So maybe the source code is online somewhere. But you know what? I've never really cared to look. Okay, so the reason hiding implementation details is so important is because implementation details tend to change over time. Ideally, this should have little effect on the people using the abstract data type. Okay, so cars have changed a great deal over the last 50 years. I bet every single component of a car from the 1950s has been improved over time. But the interface is essentially the same. Also, a foreign car might have every single component implemented differently than an American car. Okay, but I can drive a BMW as well as I can drive a Ford. Okay, and if some automotive engineer comes up with a better fuel injection system, we don't have to read a book or take a class on how to drive that car. This is because those details have been abstracted away from us. Okay, so abstraction is good. This is a good thing. And interfaces tend to stay the same over time, but implementations change. This is as true in software as it is in automobiles. So why have all the components changed from the 1950s? Well, they've gotten better over time. None of the components are worse than they used to be. That we've come up with better and newer ways of building cars. The same is true in software. Now, there are always two perspectives of an abstract data type. There's the person using the abstract data type, and then there's the person implementing the abstract data type. Okay, so the person using the abstract data type doesn't know how it works. Okay, they only need to know how to use it. So in the string class, I don't know how the string class works, and you know what? I don't really need to know how. Okay, just like we don't need to know how every single thing in a car works in order to drive it. I know practically nothing about how a car works, but I can safely drive one, and not knowing doesn't prevent me from using it. Okay, then there's the people who actually implement these things. So someone implemented the string class, but they could not have imagined every single program that would use a string. Right? So they do their best to predict how people are going to use it, but sometimes they get it wrong. Okay, so this is going to bring us to another term, encapsulation. Encapsulation is the act of hiding the implementation details and providing an interface. Object-oriented design asks us to look for things and create an abstract data type for them. And humans are really good at identifying things and assigning responsibilities to them. Now, in C++, the way we create an abstract data type is we create this thing called a class. And everything useful we find in the problem domain will become a class. So if our problem domain is we're supposed to be writing a program for students taking courses with professors, well, we'll create a student class and a course class and a professor class. Okay. We're always going to focus our efforts on identifying the data for a class and the responsibilities of that class. So as every student, we have to store some amount of data, but we also have to think, well, what actions are going to take place on that data for the student. So a C++ class groups data and operations into a single package and provides an interface. Okay, so again, a class is like a cookie cutter, just like a struct was, and the objects are like the cookies. Okay, so that's where the name object-oriented programming comes from, the fact that we really focus on the objects that get created from our classes. Now, I think I want to give you a demo of how to create a class. Okay, so I'm going to create a class that represents a time. Okay, so I'm going to create our Win32 console application. Create an empty project. This part will be exactly the same as any other program we've created in the past. So I'll create a driver first, a place to store my main function, and then I'll just put the boilerplate stuff here. Okay, so I'll run this just to make sure it works correctly. Yep. Okay, so now I'm going to, again, create this abstract data type that represents time. And to me, any time in a day, we have an hour, a minute, and a second. Okay. So rather than declaring the class up here, like all the examples I used with the struct, I pretty much define the data type up at the top of the main file. But now, because we're so focused on creating these classes, that what we're going to want to do is create these classes in their separate files. So the first thing I'm going to do is I'm going to create this thing called a header file. So I'm going to right click on the header files, say I want to add a new item, and now I'm going to select the header file type here. These files run with the extension .h. And I'm going to create a file called time.h. Okay, this is going to be the exact same name of the class. That's not strictly required, but it's a good idea, I think, to always have the file name be the same name as the class. Okay, so I'm going to say class time, and I'm going to declare an int for the hour, an int for the minute, and an int for the second. Okay, so I'm going to save that, and then I'm going to go to my main function, and I'm going to pound include time.h. So what does this mean? This means we don't really know the order the compiler is going to visit all of these CPP files. So what we have to do is we always have to, if we're going to use a data type, if we're going to use a class, we have to pound include the header file that that class is defined in. Okay. One other thing about these header files is what we'll see soon is that we're going to pound include these header files in many different places. So every time we create a header file, we're going to want to put this directive up at the top. This says pragma once, and basically what this means is if the compiler ever pound includes this time.h file more than once, it will ignore all those additional times. Okay, so this is defining a new type, and we only want to define the type once. Okay, so if that hurts your brain, don't worry too much about it. This will just be boilerplate stuff that you'll put in every single .h file that you have. Okay, so now I'm going to use my new data type. I'll create two objects, time t1 and t2. Okay, and again, very similar to what we did with the computer objects. Now we have a time object t1 and a time object t2. Each one has an hour, minute, and second. Okay, because that's the data that is defined in this class. Right. So far this looks, this looks almost identical to how we would do something with a struct, except that we pulled the definition of the class into a separate file. But basically, we have this class called time. Every time object has an hour, minute, and second, which are integers. And then over here in main, I just created two, and each one gets its own copy of that hour, minute, and second. Okay, so let me now go back here and try and set the hour. Maybe we'll set it to 4:55 and 12 seconds. Okay, so now you might notice these squiggles here. I'm gonna try and run it anyway. Okay, and it says there were errors. Okay, so let's look at these errors. It might be hard for you to read them, so I'll read them aloud. It says time hour cannot access private member declared in class time. Okay, so this idea of a private data member, what does that mean? Well, in any class, by default, all data is private. Okay? Private data is only accessible by the implementer of the class. Okay, so even though I'm writing both of these files, really you should think of the main file as being written by a totally different person. This is the person who's using the abstract data type. Okay, and since main is not being written by the implementer, they can't access private data. Okay, so that's just a rule. So, all right, well, one thing we can do is we have this keyword public. That basically what this says is anything that comes after this keyword is going to be public. Okay. So now you'll notice my squiggles go away, and if I were to see out the time here, I'll get the hour, put a colon in between there, get the minute, whoops, minute, put another colon, okay, so if I run this now, it says 4:55:12. That's exactly the data that I put inside this object. Okay, so that sounds good, but, well, what if I did something silly like this? I said the minute is going to be equal to 5,500. Right? Well, if I run it, everything will work just fine. I mean, it will compile anyway, but this does not look like a valid time at all, right? So this is really a problem because that value didn't make sense for this particular data type. No minute should ever be above 59. We really should restrict access to the data so that people don't break the rules of how a time object is used. Okay, so I'm going to go back here and change this from public to being private. Okay, and I should now get my squiggles back again once I save this. Okay, because private data is not accessible. So I'm going to have to comment these things out. Okay, so you might be thinking, well, if the data is private, if it's only accessible by the person writing the time class and not accessible by the person who's using the time class, well, that doesn't make a whole lot of sense because no one can, at least right now, no one has this ability to change the data. Okay, and this is where we're going to want to include this interface, and we're going to provide some operations or some methods that will allow us to change the data. Okay, so I'm going to talk about methods. Method is like a function. It's a block of code that the flow of control can jump to, and then eventually we'll jump back. Okay, so let me add some methods here. Okay, so I added a public section. Again, everything in the public section, okay, is always available to the to anyone basically using this data type. So if remember when the data was public, I was able to access it from main. Okay, that's because public members are available to everyone, whereas private members are only accessible to the implementers of the class. Okay, so what I've said was I'm going to include these methods, and they look like function prototypes. Remember the idea of a function prototype is the declaration of the function and then the implementation comes later. Well, that's exactly what I'm doing here. I'm saying this class called time is going to have these 6 methods: get hour, get minute, get second, and set second. And these methods are going to be written by the implementer of the time class. And I'll show you how you mark a method as being written by an implementer. Because these methods are written by the implementer, they will have access to the private data members, the hour, the minute, and the second. Okay, now typically what we do when we create a class, we create this header file, time.h. Okay, that is where we put the kind of the declaration of the class. Now the implementation of the methods, we tend to put that in a file called time.cpp. Okay. So again, I just right-click the source files. I said I want to add a new item. It's a CPP file, and I'm going to add a source file here. Now the first thing I have to do is, again, #include time.h. Okay, so notice I'm using slightly different syntax here to do my #includes. Anytime you do a #include with this less than and greater than sign, there's a standard place that the compiler looks for these. These are the common libraries that are built in to the compiler. If we want to #include something that we have written, okay, in this case we've written these header files, we use quotes. Okay, and this tool will look in the same directory that the CPP files are in. Okay, so in time.cpp, this again is where the implementation of all those methods are going to go. Okay, so let me go here, and if these are like the prototypes in a plain old C++ program, well, the implementation again is going to kind of follow this pattern where it's just the function header is just like the prototype, except that we won't have that semicolon at the end. Okay. So it's probably a good idea the first time you do this not to copy and paste. But I've done this many, many times, so I kind of know what I'm doing here. Okay, so what this says is we're going to have this method called getHour, and we want to kind of say that it belongs to the time class, right? Because it's important that we identify which methods are written by the implementer of the class and which methods are not. So for example, main is not written by the implementer of the class. It's written by someone who's using the class. So the way that you mark a method as belonging to a class is you give the name of the class and then 2 colons right after. Okay. And again, all this really says is that these methods belong to the time class. And there's some really important characteristics that go along with methods that belong to the time class. Right? Any method written by the implementer of the class can access the private data for that class. Okay. So, all right. So when we say we want to get an hour, right? Because we're in a method that starts with time : what that means is this is a method written by the implementer, and the implementer always has access to the private data. Our private data is hour, minute, and second. Okay, now how do we set an hour? Well, we pass in a value. This is the value that we want to set the hour to. But since we're in a method, we can actually verify that the passed in value is a good one. So the hour values are always between 0 and 23. So if the passed in value h is greater than or equal to 0 and less than or equal to 3, then yeah, we'll set the hour equal to h. If that's not true, we could do many things here. I'm just going to maybe set the hour equal to 0. Okay, so no matter what, if somebody tries to put a bad hour in now, like an hour 5500, since 5500 is not in the valid range, instead of storing 5500, we'll put the default value of 0 inside the set hour. Okay, so we've seen an example of a getter. I call these getters and setters. So a getter will get a private piece of data, and a setter will set a private piece of data. Okay, most getters don't have a lot of code in them, although they could. I'm going to just return the minute, the private minute member, and then again, when you're setting the minute, you'll want to do some kind of validation here. So minutes can be between 0 and 59. If they put a bad minute value in there, I'll just store a 0 there. And then same thing for the seconds. Okay, so if the past tense second is greater than or equal to 0 and less than or equal to 59, we'll set the second member equal to s. Otherwise, we'll put the default value of 0. Okay, so let's go back to main now. Oops. Let me save that and that. Okay, so we can't access the private data. We can't set the hour directly, but what we can do is call the public method called setHour. Okay, and again, we can't access the minute directly, but we can call the setter to set the minute, and lastly the second. Okay, so these are methods, these are function calls. So what's going to happen here is when the flow control gets here, we're actually going to jump into the the setHour function. And remember, each one of these objects has its own copy of the data. So when we say t1.setHour, what that's really saying is go find a thing called t1, and then call the function setHour. And because setHour refers to a private piece of data, right? When we store something inside the private hour, we're really talking about t1's hour member. Okay, so let's debug this. Okay. Now, when the little yellow arrow here is on this line, I'm going to hit F11 to step into this function. Okay, and now when we get to this point, right? H is in the right range. When we set h equal to hour, when we assign this value to hour, the compiler, the program always remembers the object to the left-hand side of the dot. In this case, it was t1. So imagine that object t1 in memory. Remember, it has its own hour, minute, and second. Okay, when we set the hour equal to h, that says we're really saying set t1's hour data member equal to h. Okay. And then when we say t1.setMinute equal to 5500, okay, well now this value 5500 is not in the right range, so we're going to go to the else. And when we set minute equal to 0, what that's really saying is we want to set t1's minute equal to 0, not t2 or any other time object, just the object to the left of the dot. And lastly, setting the second, again, we'll set t1's second. Okay. Let me also call the getters, so we can print this out. Okay, so get hour, get minute, get second. Okay, I'll just run this at full speed here, and we'll see that 4012 is actually what I was expecting, because the 5500 is a bad value. So 40 was our default value, and 12. Okay, we got that by calling again the getters, and we always remember what is the object to the left of the dot. Okay, that's the object whose data we're going to have access to inside those functions. Okay, so in a procedural program, the flow of control always moves through functions. Right? We've done that all in the intro course. We've built these functions, and we've done it a little bit in this course. All object-oriented systems are made up of many little objects. Okay, each object or each class might have many methods. So the flow of control moves through the objects. Okay, this is kind of a fundamental difference between procedural programming and object-oriented programming. Is one always has to be aware of which object owns the flow of control. Okay, right now we only have one object, but soon we'll have many objects, and the flow is going to move between the objects. Okay, also realize that we're no longer allowed to put a bad value in there. If I try and put a bad value in either the hour, minute, or second, I have some code to protect my object. I have some code to protect my data. Okay, and again, that's a benefit of object-oriented programming, is we can define this data, but also add these methods that can protect it, so that we make sure we're always using the data correctly. Okay, so when running this program, I wasn't a big fan of the output. It looked a little sloppy to me. What I think should happen is we should always have 2 digits for the hour, minute, and second. Okay, so of course I could write a bunch of code here in the driver to do that. Right? I could suppose I could check to see how many digits are in the hour, and if there's only one, add an extra 0 right before I print out the hour. Okay, I could do that, but I really think printing a time is a responsibility that belongs to the time class. Okay, so what I'm going to do is I'm going to go to the time class, and I'm going to say that I want to add this method called print. Okay, and if we have some object and we call print on it, what I want to happen is I want that object to print itself on the screen. Okay, so again, this is the public interface. This is all you have to know to use the class. Is what are the methods in the public interface? Now I'm going to go to time.cpp, and I'm going to add an implementation. Again, you always must precede the name of the method with the name of the class : : This is the only way the compiler knows that this is a method that's written by the implementer. Okay, so let's see how we're going to do this. I think we can say if we always have to print hour, then minute, then second. So one thing I could do is I could say if hour is less than 10, I know it's a 1-digit number, and I can see out maybe an extra 0. And then I could see out the hour. Okay, so I think I have to also, because I'm printing in this file, I have to pound include iostream, and say using namespace std. Okay, I could do this because, again, if I'm in a method that starts with time : I have access to all the private data. Okay, but I'm going to suggest we do something like this. I'm going to suggest we call the getHour method. Why? Because we don't in this case, but maybe there's some code, some validating that we want to do before we return the hour data member. So if we're doing some kind of, a bank account class, for example. Well, not everybody should be able to go and look at your balance. Maybe only certain people should be able to look at your balance. So if we had a get balance method, maybe we could have somebody enter in a password or a PIN code or something before we actually gave that information back. Okay, so I think it's a good idea to always use your getters and setters, even though technically we don't have to, because technically we have access to the hour, minute, and second. I think it's a good idea to do this. Okay, so we're checking the hour. If it's less than 10, we know it's a one-digit hour number, and we're going to add the extra 0. And then whether it's a one-digit number or a two-digit number, we're always going to print out the hour. And then maybe we'll add a colon. And then next we have to say, well, is the minute less than 10? If so, we'll add a 0. Okay. So notice in main I always had to give the name of an object, a dot, and then call the method. Right? So t1.getMinute, t1.getHour. When you're inside a method that starts with the name of the class, : there's an implied object that we're talking about. So if we called t1.print, okay, when we get inside this method, it's the object t1 that's the implied object to the left of the dot here. So we actually don't even have to write t1, and in fact we can't write t1 because if I wanted to call print with t2, well, that has a different name. So there's always this implied object. And if we want to call another method from within the class, we just give the name of the method and the parentheses. And the implied object will be known by the compiler. Okay, so we print out the minute, and then we'll print out maybe another colon. And lastly, we'll check the seconds. If the second is less than 10, we'll see out an extra 0. Okay, so I thought about this responsibility. I think time objects should know how to print themselves. Okay, so I added a print method, and I did a little bit of work here to make sure that the time got printed in a very readable, clean way. Okay, so notice what I'm going to do here. Instead of doing all this work to print something out, I'm just going to say t1.print. Right, print is a public method. Okay, so I have access to all the public methods. Now again, imagine you're not the same person, or the person writing main is not the same person who wrote the class. What do I really need to know about a time? Not much. I just need to know that this time class exists, and I can set the hour, minute, and second. And when I want to, I can call print, and the time should be printed. Okay. So now we have 040012. Maybe I'll put an indel here at the bottom. Okay, so no matter what values I put in here, I am now guaranteed that the hour, minute, and second are always going to be in the right range. And if I want it printed out, I as the user of the time class, I don't have to do anything other than just call print. Okay, and that's a really powerful thing, to have the implementer of the class basically responsible for all manipulation of the data for that class. Okay, let's add another responsibility to the time class. Let's say I want to be able to increment the time by 1 second. So again, every method has a return type, a name, and a parameter list, just like our functions from before. Okay, and then actually the order does not matter. You can implement these in any order that you'd like. Okay, you do, of course, have to remember to mark the method as belonging to the time class if you want to have access to the private data members. Okay, so how are we going to increment a time by exactly 1 second? Well, sounds easy, right? We should be able to set the second. So what do we set it to? Well, we first have to get the current second value and then add 1. Okay, but it's not quite this simple because if it's the 59th second in a minute and we add 1 second to that, we don't ever want the second to be equal to 60, right? Because the valid range of values for a second is between 0 and 59. We want the second value to go back to 0, and we want to add basically another minute. Okay, so what I'm going to do first is I'm going to check the value of the second to see if is it exactly equal to 59. If it is, we're going to do something special. If it's not, right, then we can just get the current second, add 1, and then call the setter. Okay, again, so if I said t1.increment, we would get t1's second value, see if it's equal to 59. If not, we would take that value, add 1, and then store that value inside the set second. Okay, so what if it does happen to be the 59th second? Well, then what we want to do is set the second equal to 0, right? Because we're basically wrapping around to the next minute. Okay, but now we have to add, a minute, because after the 59th second, we want to increase the minute by 1. Okay, but we're kind of in the same situation here where, if it happens to be the 59th minute in an hour, we have to do something special. Otherwise, we can set the minute equal to the old minute plus 1. Okay, so if when we increase the time, it happens to be the last second in a minute, well, we'll set the seconds back to 0, and now we'll check to see if it happens to be the 59th minute in an hour, right, we have to set the minute back equal to 0, and then we have the same problem with the hours, right? We need to, after the 59th minute, we need to increase to the next hour. Okay, and then we have this ability to wrap over here too. So if we're at the 23rd hour of the day, if it's 23, 59, 59, and we call increment, right, we want to set the hour, we'll wrap around back to 0. Okay, if this is not true, if it's not the 23rd hour but it is the last minute in an hour, well, then we'll just increase the hour by 1. Okay, so that was kind of a lot of work just to increment the time by 1 second, but I think it did make sense. Okay, so let's save this. And what we can do here is maybe we'll set the time to 23, 59, and 55 seconds. And then what I think I'm going to do is just set up this little loop. So maybe 20 times. Okay, what I'll do is I'll say t1.increment followed by t1.print. Maybe I'll do an indel also. Okay, and when I run this, we'll see that we incremented 56, 57, 58, 59, and then we've wrapped around to midnight, that's 0, 0, 0. Right. So if we want to do this a little more, oops. Okay, we'll see that not only does it wrap around midnight correctly, but at the first minute it wraps correctly, and so on. At the second minute, that also wrapped around correctly too. Okay, so this is really powerful, this idea of thinking of a data type and assigning not only data but methods that work on that data. Okay. Let me do one more thing here. So what I said before was, I think I said we were guaranteed to always have good data inside the time objects. Okay. Well, I'm going to comment out these calls to the setters, and I'm still going to increment and print, and we're going to see what we get here. Okay, so we get some very odd-looking times. Okay, so clearly, I was mistaken about always being sure that there's a good value inside the time objects. Okay, so this actually is a very common problem. Right. So if we had some code that looks like this, we declare this integer called x, and then the very next thing we do is we see out the value of x. Okay, this is almost always an error because here we've carved out room for the variable x, but we're using it before we assign a value. Right? So what's required is that before we use it, we assign a value to x. Okay? And if you leave that out, bad things are going to happen. I think in this tool, it won't even let us do that. It will give us this error that the variable x is being used without being initialized, right? Because before we initialize the variable x, it just has a garbage value. Okay, so the exact same thing is happening here. We have these two objects, t1 and t2, and I'm using t1 before I've set any values. Okay, now in a C++ class, we have this ability to add something called a constructor. And a constructor is a special method that's called the instant an object is created. Okay, and the syntax for this looks something like this. Okay, what this says is when you create this time object t1, I want you to call a method, that's what the parentheses mean, called the constructor, and pass in these initial values to be assigned to the private data members for object t1. Okay, so constructors are, syntax-wise, they're a little bit odd. The name of the constructor is always the name of the class, and the constructors never have a return type. Okay, so I can tell this is a constructor because it's, the name is exactly the same as the class, and there's no return type. Every other function has a return type, even void, but you can't put void behind a constructor like this. It has to have absolutely no return type. Okay, so this constructor is going to take three integers, one for the hour, minute, and second. Okay, so I'm going to go to time.cpp. This still does need to begin with the name of the class : Okay, and what I would do here is I want to set the the hour, minute, and second. And again, I could do this. Technically, I could, because I'm in a method that starts with time : I do have access to the hour private data member, but I don't think I want to do that because whenever I set the hour, I do all this validation. I don't want to copy and paste the validation stuff up here. Okay, so what I do instead is I'll just call the setter, and I'll pass in the hour. Okay, so I'll call set minute, pass in m, set second, and pass in s. Okay, so let's use the debugger and see exactly what happens here. We're not using T2 right now. I'm going to leave that out for now. And I'll start the debugger by hitting F10. And I'll hit F10 until we come to this line where there's a function call. So parentheses always indicate to me that there's a function call here. If I hit F11, okay, in this case, T1 is going to be the object that's going to be associated with this function call. And now when we call set hour, if I hit F11, right, now we can reuse all that validation code. And when we set the hour equal to h, we're really setting T1's hour equal to h. Right? We can set the minute, we can set the second. Okay. So really the constructor really is called the instant an object is created, and it's almost always used to initialize the data for an object. Okay. Now this constructor took 3 parameters. You can also have something called a default constructor. A default constructor takes no parameters. Okay. So again, there's no return type. The name of the constructor is the same name as the class, and the default constructor has no parameters. Okay, and what we're going to do here is maybe just choose some default values for the hour, minute, and second. So instead of using the passed in HM and S, maybe we will just put in all zeros. Okay, so if I suppose I could say T2.print. Right? T2 has its own copy of hour, minute, and second. So these are going to vary a little bit. They're going to vary. T1 has this time. T2 starts at midnight, basically. And yeah, the output's a little funky here. Let me put a space in between the 2 times. Okay, and you'll notice T2 didn't vary at all. It's because I forgot to call increment. I did call increment on T1. So let me call, let's say T2.increment. And now we should see it vary each iteration of the loop. It should also increase. Okay, so you'll almost always, when you're creating a class, want to have a constructor. And the constructors are used, again, just to initialize the private data. So that now I could say for sure, there's absolutely no way a bad value is going to get in the hour, minute, or second. Because the data is initialized in the constructor, and then whether I'm incrementing or printing or setting, you know, I'm 100% sure no bad data is going to get inside my time class.